Hello, boys and girls. In this short video, I am going to tell you about a really cool trick that the C compiler has and that you won't find in many textbooks, but all programming pros know about it and use it to show off, basically. This trick is called short circuit evaluation, and we'll quickly cover it in this video, and hopefully you'll use it to show off your C proficiency to your friends. So let's look at this expression. And the moment you look at it, you realize that there's something wrong with it because we are trying to divide 3 by 0, which should be, well, it should give us some sort of error, sure. But what do you think this piece of code will do in C when you try to run it? Will it give you a compilation error? Doesn't seem like it. I mean, the syntax seems fine. Will it give us a runtime error? Well, generally, when you try to divide something by 0, you do get a runtime error in C, so that's a possibility. Will you get an output of 1? Why would you do that? Would you get an output of 0? It's not clear. Well, the answer is that you will get an answer of 0. Why? Because Mr. C will not evaluate the second operand of a binary logical operator if the final result can be deduced from the first operand. Now that's a mouthful. What do I mean? Well, what I mean is that when Mr. C realizes that there's a logical operator being evaluated, he goes and looks at the truth table of the operator. So, for instance, if he is evaluating an AND statement and he sees that the LHS of the AND statement has evaluated to 0, then he knows that no matter what the value on the right hand side is going to be, the total expression is going to be 0. So to save time, he doesn't even evaluate the right hand side expression. Now this is a short circuit. This is not the way our rules of precedence have told us operators should work. It's just a cool trick that the C designers built into C for efficiency. There's no logic here. It's just efficient. Well, there is logic here. The logic is that if you know that the LHS is 0, then you don't need to know the RHS in order to correctly say that the result is 0. And similarly, if the LHS has evaluated to 1 and the operator is OR, then you don't need to evaluate the RHS, then you can immediately say that the result is 1, no matter what the value of the RHS is. Now let's see what would happen if we took a slightly more complicated expression. What would happen in this case? So here we have a number of expressions that have to be evaluated. And since the associativity of these expressions goes from left to right, they're all relational or arithmetic operators. We have the first one being evaluated here within the smallest brackets. 2 is greater than 5? No, that's false. So you get a 0, and the 0 is being evaluated against this right hand side. But since this is an AND, then because of the short circuit evaluation, this whole thing is evaluated to 0 to begin with. And since this whole thing is 0, then with this NOT, it becomes 1. And now because you have 1 on the LHS, then what does the short circuit evaluation of this whole thing becomes? It becomes 1. So the whole thing, even though there are 2 divide by zeros in it, it actually evaluates to a reasonable answer. And this is what I wanted to show you, this little trick of Mr. C, where the second operand of a logical operator is not evaluated when the very first operator is sufficient, or the very first evaluation is sufficient to give us the final result.